Awesome. All right, so welcome everybody. It's once again very nice to have you all here. Hello to the people online. Today, giving our seminar is Josh Wilson, who's a PhD candidate working with Katsuya Amano and Rich Fuller here at CBCS, and he's going to talk about uncrewed aerial vehicles and endangered shorebirds. So I'm going to let you take it away.
Thanks very much. Thank you everyone for joining me this morning. So I'm Josh Wilson. I'm a PhD student here at UQ, working with Rich Fuller and Katsuya Amano, and basically looking at whether we can use drones to survey shorebirds. Before I get into it too much, I want to acknowledge the traditional owners and their custodianship of the lands on which we meet, and I pay my respect to their elders, past, present, and emerging. So shorebirds, I'm sure a lot of you already know what shorebirds are, but I'll give a very quick overview. They're this amazing, diverse group of birds that are basically commonly found along the shoreline, foraging on the mudflat or in the shallow water. So they rely on these intertidal habitats to get their energy and their fuel they need to live, and for many of them to migrate to the northern hemisphere where they breed. So they have a lot of different remarkable traits, and I think it's really important that we conserve them. Unfortunately, they face a number of different threats, and a lot of their populations are declining. And one potential threat, and it looks like this video is not playing that well, but is disturbance. So this is a video of a drone approaching a flock of royal spoonbill, not technically shorebirds, but it demonstrates that the drone can cause disturbance. So it's something we need to consider with the increasing use of drones. At the same time, shorebirds spread out over these massive intertidal areas to feed. And what we really need to develop effective management action and to assess that action to see whether it's working is accurate abundance and distribution data. And it's really difficult to get that information when the birds is spread out over such a large area, because ground-based surveys are not practical in this sort of environment. So potentially we can use drones to access these inaccessible areas and survey them more accurately and over more extensive areas. For example, this is a video I took of some shorebirds, and it's a bit jittery, but you can see that you get a completely different perspective where you can now fly the drone out a kilometre and survey this flock of birds that's sitting out on the intertidal habitat and get a really good idea of where the birds are, what areas of the mudflat they're using, what organisms in the mud they're relying on, and things like that. So what we need to inform both of those actions, first of all, regulating drone use near shorebirds to mitigate disturbance, and informing the use of drones for surveying shorebirds, is information about how the shorebirds respond to the drone. So that was what I looked at in this project. So basically, we conducted 240 approaches of roosting flocks of mixed shorebird species throughout Moreton Bay. And we looked at 3 different predictor categories. The environment, so things like wind speed, temperature, location, the stimulus, which is the type of drone that we're using and how we're flying it, the target, which are the type of bird, the species of bird, and the composition of the flock. And what we were looking for as a response was the flight initiation distance. So how close we could get to the birds before they took flight. That's the information that we need to inform these surveys and to inform disturbance mitigation strategies. So we looked at a number of predictors, as I just discussed, in those 3 categories, but I want to talk about 6 in particular. First is the position of the drone, the species of the bird, the type of drone we're using, habituation, so if I approach them over and over again, do they get less or more susceptible to disturbance? If we put barriers between it, like trees, does that decrease the disturbance? And what about if there's a mixed species flock with birds with different sensitivity? Are some of those species acting as alarm signals for the other species in the flock? So what's the interaction like between the species? So first of all, looking at position, And I'm going to reference this hazard rate term, which is a little bit confusing, but basically it is how many flight events are likely to occur in 1 second, given those predictors. So if it's 10, it means that 10 flight events would occur in that 1 second time interval. But basically it's a measure of how likely the birds are to take flight. So if that number is higher, the birds are more likely to take flight. So here we have a plot looking at the horizontal distance between the drone and the birds. And we can see that, as you would expect, as you get closer to them, you see an increase in disturbance. And that particularly starts to get worrying once you get closer than about 200 meters. And this is the same plot, but broken up by different species. And we're looking now at the altitude of the drone instead of the horizontal distance. And what we see for the most part is that as you fly higher, the disturbance decreases, which is exactly what you would expect intuitively. But frustratingly, the eastern curlew didn't behave that way. We found that as we flew higher, they actually took flight when the drone was further away, which was counterintuitive and started to kind of ring alarm bells for us about the eastern curlew being a little bit different to most of the other species we were looking at. So then we looked at the different species and their likelihood of taking flight. And again, we see the eastern curlew here stands apart from the rest of the shorebird species we looked at. And that most other species have kind of a somewhat similar range with those confidence intervals, but the eastern curlew seems to stand apart. Looking at drone, we tested 4 different types of drone and intuitively found that the larger drones, the louder drones, cause more disturbance than smaller drones, which is what you would expect. And then looking at habituation, we found that as you conducted more and more approaches, the birds got less likely to take flight. So again, that's quite an intuitive finding. So it's nice when you put things into a model and it comes out with stuff like this. And then when you fly the drone behind trees and barriers so that they can't visually see it, they can only hear it. Again, that reduces the disturbance. And this is the plot that we really want to produce from this analysis, which is looking at the probability that the birds will take flight when the drone's at different positions. So these contours, darker contours, represent a higher probability of the birds taking flight. And we have, on the y-axis, we have the altitude of the drone, and on the x-axis, we have the horizontal distance. So you can see that for pied still, they're very unlikely to take flight even when you're down at 30 meters. And this is with a drone that's about 30 centimeters by 30 centimeters. So like the typical small consumer drone that's going to be flown along our coastlines recreational. So for pied still, it kind of implies that drones are probably not going to be this massive source of disturbance, provided that they're flown above 30 meters and the drones are kept small. So expanding that to all of the 12 species that we included in our analysis from these mixed species flocks, and we find that there's kind of a similar trend across most of the other species. It increases for some species, but for most other species, it's below 60 meters. So if you're flying the drone above 60 meters and it's one of those small drones, the birds are pretty unlikely to take flight, which is a really valuable finding for surveying these birds. And also it can be tied into disturbance management by organisations like Queensland Parks and Wildlife Service. So what we also found though is this plot up in the top left, which looks at eastern curlew, and we found that they behaved significantly different from all the other species. They took flight every time we tried to approach them, often at distances in excess of 100 meters, sometimes more than 200 meters. And again, we see that increase in disturbance as the drone gets higher. So that's a really worrying sign. The eastern curlew is a critically endangered shorebird species. It's facing habitat degradation all along its flyway, particularly in the Yellow Sea area. And one of the things that's contributing to that is disturbance. So with drone use increasing, we could see this start to play a larger role and start to contribute to the degradation of those habitats. So now we ask the question, well, if there's these mixed species flocks with eastern curlew and they're really sensitive, how are these other species reacting to the eastern curlew taking flight? And that's what this species here this plot here looks at. So we've got those contours that we saw on the last plot, which is where we would expect the birds to take flight. And these black dots are when they've taken flight just after eastern curlew. So eastern curlew have taken off, and then these species have also taken off. And we can see that it's well outside their range that we would expect them to be taking flight. So it means that in these mixed species flocks, the whole flock actually behaves as if they were the most sensitive species, because they're reacting to that species response. So it takes flight, and the eastern curlew is often screeching out alarm calls and things like that. And the other birds are picking up on that and recognizing that there might be a threat, and they're taking flight as well, which is an intuitive finding, but has quite far-reaching consequences, because typically the regulation of disturbance and things like that is done on a species basis. When really what we're seeing is that even though the pike still isn't that susceptible to drone-induced disturbance, if it's in a mixed flock with eastern curlew, it essentially is. And the disturbance impacts can be much further reaching than just each individual species. So there's basically three main findings from the study. The overview is that most species are not going to respond to a drone if it's flown above 60 meters. The eastern curlew stands apart from most of the other species we approached. It's highly susceptible to disturbance, and that the eastern curlew acts as a sentinel species in these mixed species flocks. And so our conclusion is that we really need to start looking at regulating drone use near shorebird habitats that are going to contain these highly sensitive species, and the regulations need to be based on the most sensitive species likely to be in that flock. And on a flock-wide basis, not a species-by-species basis. So we then thought, okay, we've done this research, how do we convert it into management action? So we got in contact with the Civil Aviation Safety Authority, who manages drone use in Australia, and Queensland Parks and Wildlife Service. And basically the Civil Aviation Safety Authority says that wildlife, drone use near wildlife is regulated by the states, and you need to look at state rules to inform how you fly a drone around wildlife. This is the only thing about wildlife in their regulations. And then, so we contacted the Queensland Parks and Wildlife Service, and they basically, they supported the research. So they were really interested in finding out how the birds reacted. But shorebirds are already protected in a lot of marine parks, including the Moreton Bay Marine Park, and it's an offence to disturb them. So drone-induced shorebird disturbance falls under that banner. And it's really now a matter of information. So how can we let the public know that drones fall under that banner of disturbance and can be a significant source of disturbance for some of these shorebirds which are critically endangered, and they can contribute to habitat degradation and ultimately population declines. So we reached out to the media, which was, I guess, risky, but and using UQ Media, who helps kind of get these this research out there, submitted it to a bunch of different places, and that got a really good response. There was a lot of media attention, and so hopefully that's enabled people to, that's kind of increased the knowledge around this, and now the public are somewhat more aware that drones can cause disturbance to shorebirds, and that can help drone pilots modify their flight paths and things like that to avoid disturbance. And the Queensland Parks and Wildlife Service have now put in drone regulations in the marine park. So you've always needed a permit to fly in the marine park, but now that permit is kind of backed up by some of the information that we got. So if you want to fly for filming purposes or even research purposes, they now have a sheet that kind of specifies some of that information we looked at earlier about how close you can approach to different species and that information. So hopefully we've been able to convert some of the research into kind of management outcomes. And in terms of surveying the birds, that's the chapter that I'm working on at the moment. So working on Minjerribah with Kayak and the Queensland Parks and Wildlife Service and some of the rangers out there to try and conduct some of these surveys. Obviously the eastern curlew is a bit of an issue that we're going to try and navigate, and with how we structure the surveys to try and minimise disturbance while still getting the benefits out of using a drone in these areas. So yeah, I was just out last week trying to survey some of the massive intertidal mudflats. So really exciting stuff, and it's underpinned by this research that we did earlier. That's it for me, a bit shorter one today, but I hope it was informative. If you want to know more, you can always email me or min507 if you come and see me. Or you can reach out. The Morecambe Bay Foundation supported this research. They have a blog on it on their website, and the Queensland Way to Study group as well supported the work, and they are the ones that actually go out and do these surveys. So if you want to get involved in on-ground shorebird surveys, they're the people to contact, and hopefully they'll be using drones in the future. And yeah, I also really want to thank Kate for organising this seminar. It flows so smoothly because of the work you put in, so thanks very much. And thanks everyone else for coming.
Any questions?
So how the one thing that is great talk. I'm very excited to hear more about it this Friday, where Josh is going to come on a field trip for one of my courses.
Yeah.
So super excited about that, and thank you to Lee for putting it together. I'm curious. The one part of that I was waiting for the information was how close do you actually need to be to do the survey, right? Like, can you do the surveys from 1,000 meters?
Yeah.
Yeah.
So what we found is that basically the metric that you need is how many pixels do you need on a bird to be able to identify that it's a bird, and how many pixels do you need on that bird to be able to identify its species versus other similar species. And it obviously depends on what species you're looking at, and how big the bird is and things like that. So something like a pelican, you can survey at like 180 meters and you'll still be able to go, that's a pelican, because it's massive. So I think we found you need about 200 pixels on the bird. So for smaller birds, that's actually quite low. So 60 meters, you can identify kind of medium bodied species, ducks and things like that. But for the smaller shorebird species, you would have to, with this sort of drone, which is just like a $3,000 consumer drone, you would have to fly really low. So that's one of the things we'll be talking about in this next chapter, which is kind of what can you do with a consumer drone at the moment, and what would you need if you wanted to do some massive extensive survey effort, in terms of what camera you would need and the resolution. For something like an eastern curlew, I think you're probably looking at around 60 or 70 meters to be able to identify it and its species. So it's basically unfeasible, because they're going to be disturbed at that altitude. So what you would need then is to fly a bigger drone with a better camera. You need to get CASA approval to fly above 120 meters. You need to get CASA approval to fly beyond line of sight. And it just becomes this massive operation. So I was hoping to develop something that could be picked up by kind of small organizations like the Queensland Way to Study group that don't have $100,000 sitting around to spend on a drone. But it turns out that while this is useful in some instances, it's not kind of a blanket solution, because of species like the eastern curlew and the image resolution stuff. So yeah, but most of the time about 60 meters will be enough to find the birds at least. So yeah.
A small follow-up question. So those $100,000 or $50,000, $10,000 fixed-wing drones, the camera system is, I mean, you can't put those cameras on something this size. They're just a bigger camera that's required. I'm assuming it's not just the drone technology, but it's just how big a camera, how big this camera can be, how big this lens on the camera that allows you to do that sort of thing.
Yeah. So they generally get bigger and heavier, so you need a bigger and heavier drone. But also one of the limiting factors is with a small drone like this, the amount of area that it can cover is actually not that big. Like maybe it can fly 5 kilometers before you start to get it run into battery life issues and things like that. And you can change batteries and stuff, but it doesn't extend the range that much further than someone just standing there with a spotting scope. So that's one of the things that we found. So it's kind of working within those constraints to find the best way to survey it. And one of the ways to remove those constraints by getting this massive fixed wing that can fly for 2 hours and can survey the whole coastline of Endangered in one go. So yeah, that's one solution, but it's not the solution that I'm looking at because I'm trying to make it kind of accessible for small organizations.
So many questions. How does Kayak feel about drones for researching drones just in general on the general?
They've been supportive of the project, so I contacted them and we went through and they are supportive of it, but I think like most people are, they're a bit wary of using drones in general because I think mainly for them because of the risk of disturbance to wildlife. So they do have a drone policy that kind of outlines similar rules to CASA that they send out to researchers, but basically in terms of my work, they just want to be included and involved and come out and see how the birds are reacting firsthand and understand the impacts that drone surveys are having. And provided there's not extensive disturbance, I think they're in support of it. But yeah, it's just a interesting one to navigate with anyone using drones because they're a bit intrusive, I think, on business plans. So, yeah.
More, I guess, along the same lines of management, that there's a balancing act of like not over-regulating, but still having something that's enforceable. I'm just interested in your opinion on including distance limits in regulation, because yeah, having that outcomes based of like not disturbing the shorebird is great, but without that information of like knowing the species and knowing the distances beforehand, you're not going to achieve that outcome. Do you think that governments should be enforcing distance limits, or do you think that they should be sticking to the communication side of things?
I think that it's impractical to try and enforce distance limits with the resources that someone like Queensland Parks and Wildlife Service have. So I think what they're doing now is this blanket rule that's like the service to shorebirds is prohibited. Although I would say that that's probably very, very rarely been enforced. But having that blanket rule and then just trying to put out information, trying to put up signs and things like that. Yeah, it's a really hard issue to manage, even when you have the person there walking onto the mudflat disturbing the birds. They're rarely going to have any sort of penalty from that. And then you get someone with a drone where they could be a kilometre up the coastline flying the drone over. Yeah, I think it's just really tough to enforce. So maybe signs and information is kind of the way to go. But yeah, if CASA were to get involved, it could be different because CASA is like they're like a legal entity sort of thing, and I'm not a policy maker or anything like that. But they at the moment are basically just saying it's regulated by like states and national parks and things like that. So,
yeah, how does that compare then with Wales? Because Wales, they have a distance.
yeah, I think so. On this last slide, they say the New South Wales government states that drones must not be flying within 100 metres of marine mammals. And that's like the wildlife. That's like the only specific wildlife that they focus on. And I love it because probably some researcher went and did an approach to marine mammals and then came up with that number.
Yeah.
But it's the only one that CASA mentions, which is funny.
Well, and some marine mammals don't care. So.
Yeah, yeah. So anyway, so it can get in there, but yeah, I think at the moment it looks like it's probably going to be national parks that do most of the regulation. And then outside of a national park, it's just relying on people being on the problem. Yes.
Yeah, thank you for the interesting talk. I think CASA could be interesting if we got a human focus. For example, like aerospace, lower aerospace in the future. In some city already, they are using the drone to deliver Amazon.
Yeah.
So maybe you can argue if we research more on the impact of the drone on birds. Because they run a conference called Bird Hazard Conference every year, or that we call conservation and connectivity. So they run how to manage the hazard. So if we know about how different birds may react to the different drone and through like different space, like orientational or the height, so it may cause different potential for the drone attack.
Yeah.
So it may have very practical application not only for the research, but for example, how you can design the warehouse, how to design the delivery kind of routes to make sure that human safety when you see the drone delivering things. So maybe.
And I guess if these massive flocks are taking flight, it does ironically, it puts those drones at risk that are trying to deliver packages and things like that.
Yeah, it's already happening right now. So I'm thinking it could be one day here, but like nobody from conservation community is involved in the trafficking you're designing. So
Yeah.
it could be big hazard for the birds.
Yeah.
And.
Yeah.
This community. Sorry, so random.
That's good, interesting perspective, yeah. Go on, Lena.
I don't know much at all about drones. So my question is there a lot of variation in how big or how noisy the drones they show constitute encountering would that affect anything? Because
Yeah.
the ones that are quite large and quite small and quite noisy.
Yeah, most of the drones, even the commercial drones are like under probably a meter wide. So they're all kind of roughly the same size. But the main difference is fixed wing versus rotor wing drones. So the ones that can hover in the same spot and produce lift from their propellers versus the ones that produce lift from wings. They're completely different shapes and sizes and things like that and noise levels. So those two different categories could have remarkably different impacts on the bird response. But within each of those categories, we saw that even within, I specifically looked at the rotor wing drones. Even within that category, the larger drone causes more disturbance, and it's louder as well. So, yeah, but I think probably the biggest difference would be between those two main categories.
Yeah. So, what are the ecological hypotheses that you have for Eastern Curlew being the most alert to drones?
So the ecological,
Like reasoning or hypothesis?
oh right. You're more of a bird than I am.
I mean, I have no idea, but I would imagine like bigger birds would be less alerted by the drones if we consider it like an aerial predator.
Yeah,
But I think Eastern Curlew is like a large shorebird itself.
yeah.
So I'm curious that, but and I remember probably do you have like data for species like red states or compare?
One of the ones that is an interesting comparison is whimbrel. They're very closely related, and the whimbrel is not very susceptible to disturbance, whereas the Eastern Curlew is. So that's a species that has a very similar habitat niche, body structure, and yet completely different response. So I don't know why the Eastern Curlew stands out from the other species as being more susceptible to disturbance. Obviously, it's a bit larger than the whimbrel, but yeah. Some theories that I've read in other papers looking at like human-induced disturbance and things like that, like organ size, so bigger sensory organs like eyes and things like that, and then body size being an impacting factor. Larger birds maybe needing more time to take flight or being at risk of predation, things like that. But yeah, I think that one of the reasons why they potentially were more susceptible to disturbance when the drone was flown higher is because that might mimic closer a predatory bird flight. So yeah, rather than a flight that's at 20 meters altitude coming in quite low. So yeah, but that's a whole different study to look at the reasoning behind the different responses. Yeah.
Just wonder which months did you conduct your experiment and whether it's like at a high tide or low tide?
Yeah, good question.
Yeah.
So it was at high tide, and we avoided the months of migration. So like the month leading up to migration and the month after they returned. And I think that basically because we didn't want to disturb them too much near that period. But it would be interesting to see if their response changes near migration because their risk kind of adversity might shift when they really need to conserve their energy more. So they might be less likely to take flight in that period.
Yeah.
But yeah, we avoided getting involved in that because we didn't want to have too much of an impact on the birds.
Yeah. I mean, personal migration, I mean, I do both and shorebird, and they are a lot easier to catch when they're migrating.
Yeah.
And the returning ones, which we can never catch.
Yeah.
Yeah, so it would be interesting too.
Well, one of the species that we did study was bar-tailed godwit, and there's so many of them throughout Moreton Bay that I thought for sure we'd have like a clear picture of how they respond. But sometimes I could fly like 20 meters above them and they wouldn't care, and sometimes I'd be at 120 meters, 50 meters away, and they'd fly away. And that difference in response could have been due to the months that we were doing it and getting closer and closer to migration. So, yeah.
Question from the chat.
Oh, yeah.
Thanks, remarkable work about the influence of UAVs on shorebirds. It's going to be helpful for their protection. The question is, do you think the sensitivity of barristering curlews is decided by its inherent character, such as genes or hunting pressure from East Asia?
I don't know. I think that I'll come back to the example of the whimbrel where you have a very similar species in terms of like the taxonomic rank and the life history, and yet you get a completely different response. So I don't know. I don't know why the eastern curlew are reacting differently, but they're typically a shorebird that's sensitive to disturbance from other sources as well. So it might just be a trait of them, but I don't know why. But it's interesting. Yeah. Same.
How bad was the ethics? Like you specifically say that's the purpose of doing it.
Yeah, it was a long time ago now, so I think I've repressed most of those memories. But no, to be honest, I don't think it was that bad. I don't think it was too bad. I was doing this part-time initially for the first year of doing my PhD. So it meant that I could just receive emails about ethics, change things and do it. And I was only working 1 day a week. So the time frame that I was working on was more similar to the time frame that the ethics people work on. Not that they're only working 1 day a week, just that things take months to get through. So yeah, so it wasn't too bad in the end. Yeah. Yes.
In terms of not wanting to fly a drone near an eastern curlew, how well is the distribution of that bird known? Because if you can't tell that it's an eastern curlew until you're at 60 meters, you've already disturbed it.
Yeah.
So is it really well known where they occur?
It's not that well known where they forage and things like that, but generally they will occur on most of the mudflats throughout Moreton Bay. So you're always at risk of there being an eastern curlew there. So yeah, it's an interesting problem that we're kind of just starting to get to grips with now of like where does drone surveys fit in terms of disturbance to eastern curlew if they may be all throughout the intertidal habitat. So yeah, kind of thinking about how to navigate that at the moment and what to do. Yeah.